Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900. Tonight's flight we're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, let's localize and landing surround the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, and the vertical rate of climb descent of the aircraft in 10 hundredths of 1,000 feet per minute. Or the steepness of the trigonometric angles increase can climb descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease, and the bank angle indicates. Also the Lszh localizer. We have the horizontal localizer and the vertical glide slope that receives the radio frequency from the threshold antennas of the runways we use for takeoff and for landing. So we have the runway 14 over here. You can see in the Zurich International Airport, Lszh in Switzerland. So we have the runway over here. You can see we can use for takeoff and for landing. We're going to be aligned with a unique radio frequency for each runway we use for takeoff and for landing, and it's a unique heading. So this will be aligned with the horizontal localizer and vertical glide slope, the Lszh localizer or instrument landing system of the runways and airports we use. So we're gonna have also the Lszh localizer crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, the flight mode and zero with the autopilot and the auto throttle, lateral and vertical navigation modes, the HSI, the horizontal situation indicator with magnetic heading and track, also the decorative display of the flight plan. You can see the flight plan we're gonna create using the flight management computer. I'm gonna show you in a couple of minutes. I'm gonna input all the data of the aircraft for this flight, and we're gonna create a flight plan or a flight path or a route. Is gonna be connected with a waypoint by waypoint route one by one. So you will see how we're gonna achieve that. Also, I'm gonna show you. We're gonna be having also over here. So we're gonna be having also the navigation display. The navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see how far above the ground we're gonna be flying. Also the horizontal, you can see the airports where they are located in the terrain map. Using the GPS, we have the terrain and weather reflections from the weather radar. You can see the red, green, and yellow and amber indications of the terrain depending on the elevation and the distance around us, and also below as we fly in the vertical display and also in the horizontal. You can see also the airports where they are located in the terrain map, the work stations, the ADLs. We have the navigation aids, the nav aids. Also we have the waypoints, which are horizontal vertical navigation fixes and altitude and speed constraints. The aircraft we're gonna have to fly through some waypoints during this flight. You're gonna see how we're gonna make that. So we're gonna select from the flight management computer, as I'm gonna show you in a couple of minutes, every waypoint that we need to fly through using the flight management computer. We're gonna create the flight plan. Also it's gonna be interconnected with the autopilot and auto throttle and the flight director, with the LNAV, the VNAV, the lateral navigation, the vertical navigation of the aircraft. So I'm gonna show you that. I'm gonna show you the navigation display. Also displays, we're gonna see the purple or magenta line of the flight plan. We can see also in the navigation display we have the display of other aircraft. You can see using the transponder, THB and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft. You can calculate using its radio frequency computer the other aircraft position, distance from our aircraft, altitude difference from our aircraft, how many hundreds and thousands feet are above or below our aircraft. Also whether they climb or descend with respect to our aircraft. Also you can calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning we have an incoming collision in the air using the TCAS system, the traffic collision and advisory system. So we'll have to make an avoidance maneuver in the air. Also we can see the diamond shape of the other aircraft displayed in the navigation display. We can see also in the when we are in the airport, we can see the other aircraft in the runways and the taxiways. So we have all these things. We have also the magnetic North Pole and the geographic North Pole, the magnetic variation depending on where we are in the world. Also the display of other airports with the distance. So we're gonna have a few things to see using setting up all the instruments of the aircraft and the systems like the autopilot flight director system panel, the flight controls, the engine thrust. So I'm gonna show you all systems one by one. You can see here I'm having this side stick I can use to control the aircraft in flight. The Logitech Extreme 3D, so we can climb, we can descend, we can make turns to the right, turns to the left. We can use the rudder pedals also for directional steering. So you can see the side stick similar to the Airbus. We have the Airbus, the side stick priority button, the autopilot disengage, and the push to talk button. So you can climb, you can descend like this. Side stick in the Airbus, up, back and forth. You climb, descend. It's the yoke back and forth in the Boeing. Also make turns left and right. Is the side stick left and right in the Airbus. Is the control wheel over here of the yoke, left and right. So it's similar flight controls, no difference as you can see. Also we can see here we're gonna see all the aircraft systems one by one. So we're gonna see all the systems of the aircraft. You're gonna see also so you can see the side stick I use for climb and for descent. The flight controls of the aircraft you can see outside also. We have here you can see the airport that we are located here. Hope you have a good view from the screen, a clear view. So you can see the flight controls, we can climb and we can descend using the outside view. Climb, descend, use the horizontal trim stabilizer also we have for the horizontal stabilizer here in the elevator. As we climb and we descend, we can use the horizontal trim of the aircraft for the Boeing or the Airbus aircraft. We can trim the aircraft stabilizer in the air so we can balance the aircraft. We can use the rudder pedals, left and right, directional control, yelling turns in the air and in the ground. Also ailerons and spoilers make left and right bang roll turns as you can see. So side stick left is a left turns, side stick right is the same like control wheel left and right in the Boeing aircraft, no difference. Also for the Embraer and the Canadair CRJ aircraft, same flight controls, no difference. Also you can see, I'm gonna show you, we have the thrust levers here. You can see we can adjust the thrust using this stick here. So you can move the thrust levers back and forth. We can actuate the thrust commanded by the engines, by the fatigues. So we will increase or decrease the thrust commanded here. As you can see we're not configured for takeoff yet, so it will give us the warning here from the flight management computer, from the ECAM, from the monitoring system of the aircraft. the ACAS axle in the Boeing, and indication for the system display. So you can see the engines thrust increase and decrease over here. We can see the flight controls movement back and forth. You can see we have the rudder pedals for directional control. I have in the side sticks. You can see the rudder pedals control the vertical rudder, also control the nose wheel steering. Over here we have the tiller for the nose wheel steering. I will show you. We have also the horizontal trim stabilizer. You can see here this trim switch is also in a couple of minutes. You can see the parking brakes up and down here. So this is the parking brakes applied. We have also the horizontal trim stabilizer, climb descent. You can see nose up and nose down with the elevator trim, alternate pitch trim as it says. So you trim the elevator, the horizontal stabilizer in some aircraft, the horizontal elevator, some other. You have also the stabilizer cutoff switch here. So I'll show you one by one system. You can see the position of the horizontal stabilizer of the tail of the aircraft. You can see stabilizer trimmed here, nose up, nose down. How many degrees right now is 4.25. is set for takeoff inside the green band. You can see ND nose down and NU is nose up. Rudder trim also. The flaps position, cabin pressurization, altitude as we fly. So I'll show you the engines indications also. The primary flight display over here. The navigation display. Autopilot flight director system panel over here. Settings for the barometric pressure also over here. The FS panel and the systems indication. So you're gonna see all the systems. You can see the thrust levers. We have the fuel, also control system, fuel valves on and off. We can turn on and off the engines by setting the engines control here. Start system, electronic engine control in the overhead panel. So I'm gonna show you later that. Also electrical, the APU, the auxiliary power unit. We're gonna set. We're gonna start the engines. You can see the cabin pressurization here, displayed in the engines indication. We have the outflow. Also you can use manual or automatic control. So I'm gonna show you here. You can see so you're gonna see all the systems. I will continue now with the outside view of the aircraft. I will talk to you about all the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying all the aircraft. For the air transport pilot license and the commercial pilot license, we need to know the aerodynamics, the Bernoulli theory of fluids, and the Newton's physics. So we need to know some general physics. So I will show you the outside view and derive some principles we need to know. So I will explain also the setup here. I have the computer for controlling the aircraft, as you can see. So you can see also I have the mouse pad, the keyboard to control my computer. So I have the keyboard input over here, so I can control the Boeing 787 in the Microsoft Flight Simulator, as you can see. Also the side stick. This is the full setup. So we need to know the outside view now of the aircraft. Continue with the aerodynamics. We need to know for the air transfer pilot license and the commercial pilot license. So we go over here. You can see we have the outside view of the aircraft. You can see the outside view. You can see the forward wings of the aircraft hold the weight of the aircraft as the aircraft flies. You can see the mean aerodynamic chord position over here. The Mach, it's 33% of the mean aerodynamic chord, with the maximum aerodynamic lift occurs in the forward wings. Is also the position where the stall begins. The airflow becomes detached as we fly. The aircraft, also the center of pressure is moving back and forth over the top surface of the wings. So when we have the stall over here, we need to monitor inside the aircraft. So you see the primary flight display, you can see the airspeed indicated over here, and we have also the stall speed indicated. So you can see the airspeed tape, you can see the stall speed with a red and amber yellow indication over here. When flying, so we need to apply the side stick down in the Airbus aircraft, and also the yoke in the Boeing, and also the thrust levers forward to increase the thrust, decrease the angle of attack of the aircraft as we fly, using the side stick down. So this is the stall avoidance maneuver. We need the mean aerodynamic chord. We have also the thrust from the engines, the propulsion system. You can see the engines, the high pressure compressor and turbine over here, the back side of the engine, and the front side is the low pressure compressor and turbine, and the fan stage over here. We have also the low speed starter and the high speed starter. We have the exhaust jet blast from the engines. We have the bypasser over here. So we have the thrust vectors over here that push the aircraft forward. Also we can see the fuel lines in the top surface over here. The fuel control, the wing and engine RDIs over here in the front. So we have the fuel tanks, the left wing tank and the right wing tank and the center tank. So we have 30% right now, and 30% left and right wing tank, and 10% in the center tank. We have balance between the left and the right wing. We have also, you can see the mean aerodynamic chord. We have the center of gravity down here, transverses through where this point is approximately. So we have the yawing axis of control of the aircraft. We can yaw the aircraft using the rudder pedals left and right. The rudder left and right turns, as you can see. Directional control, also we can use the nose wheel of the aircraft to make left and right turns, like 76 degrees alongside with the rudder, left and right from 0 to like 45 knots or 70 kilometers an hour in takeoff. Then it decreases as we increase the airspeed. We have the rudder aerodynamically effective of 45 knots, 70 kilometers an hour approximately, or 80. So we have the nose wheel will decrease from 76 degrees deflection left and right to like 7.6 from the computer automatically, as we increase the airspeed, as the rudder becomes aerodynamically effective. Also as we increase the airspeed above 144 kilometers an hour, or about 80 knots, we have the nose wheel deflects to zero position. It's locked to zero deflection from the computer. So we have only the rudder to control the aircraft above 144 kilometers an hour in takeoff. Also in landing we is doing the vice versa from the computers. It's the inverse flow. So we have both this nose wheel and the rudder. From the rudder pedals, I have in the side stick the rudder pedals, so you can see the rudder pedals again. Here we control left and right nose wheel steering and the vertical stabilizer control. Also we have the toe brakes. We can apply the toe brakes when we press the top surface. We have for the nose wheel also the tiller here in the left and the right side over here. So we can see also we have over here. Also we have this the horizontal, the wingtip. The wingtip is the pitch axis of the aircraft. Is the side stick climb and descent for the Airbus. As you can see, climb, descend the Airbus back and forth. Side stick is climb and descend using the elevator, the tail of the aircraft, the horizontal stabilizer or horizontal tail as you called it. As you can see, so you can take the weight up or take the weight down. We climb or we descend. So we do the same for the other flight controls. You can see also we have an incoming aircraft for landing over here, a Boeing 737. Here we have it. This is bottom. So we're gonna see this is the pitch axis. So the pitch axis is back and forth. The elevator in the Airbus is the side stick. In the Boeing is the control column of the yoke of the Boeing aircraft. So you move back and forth the control column, you climb, descent like this. Same thing in the Airbus and the Boeing, no difference of the flight control system, same principles and same feeling. So we have also, as you can see, ailerons and spoilers. So this is the pitch axis. We have one more axis, is the longitudinal axis from nose to tail of the aircraft, transverses the other axis, so we can make left and right turns, ailerons and spoilers. In the Airbus, side stick left and right in the Airbus moves the ailerons and the spoilers for making left and right turns, differential lift from the left and the right wings. As you can see, left and right turns, side stick left and right in the Airbus. Also is the control wheel left and right in the Boeing. So in the Boeing also you have aileron, spoilers and the flapper on surface to control the turn left and right. So we see the control wheel for the longitudinal or roll axis of the aircraft, left and right turns over here. So we have full flight controls, the elevator, ailerons and spoilers, left and right turns, rudder and the nose wheel steering. In the ground, the nose wheel using the rudder pedals. So we have full flight controls. We have also the horizontal stabilizer trim over here. As you can see, all flight control surfaces move together, both the captain and the first officer in the Boeing aircraft, they're interconnected. Also the rudder pedals are interconnected. In the Airbus we have the side stick priority, you can take either side or have dual input. You have the autopilot disengage also, side stick priority and the push to talk over here. So also in the Airbus we have the rudder pedals interconnected, move together in flight. So I'm gonna show you now the rest of the systems. I'm gonna show you also the horizontal trim stabilizer here very quickly. This is the horizontal tail elevator trim, up and down. Over here move the elevator up and move the elevator down, so you see horizontal tail over here. So you see horizontal elevator over here, climb and descent, move the elevator up and down. We have elevator, so you can read the tag here, elevator trim, left click down, right click up. So you see this is for the elevator control of all aircraft. You have that have a yoke like in the Boeing. Others have the trim wheel and they do the same function, so you trim the elevator up and down like this. This way you trim the elevator up, this way you trim the elevator up. As you trim the elevator up, you pitch the nose up, this aerodynamic effect. As you trim the elevator down, you pitch the nose down, this aerodynamic effect in flight. Elevator trim, left click down, right click. So you up, we have the flap speeds also displayed, the autopilot disengage switch here, and the head up display declutter over here. So we have the flight control computers of the Boeing aircraft, as you can see. Flight control computer surface over here in the overhead panel. In the auto position, this is a fly-by-wire aircraft. It has its flight control computers. So when you move the horizontal stabilizer or the flight controls, like the control column and the rudder pedals, you give a command to the flight control computers to actuate the position. So we have the horizontal trim stabilizer, the alternate pitch trim channel over here. We trim the elevator up and down like this. Also, you see the elevator up, nose up effect, and the elevator down is the nose down effect over here. Also, we have the cutoff switch for the horizontal trim stabilizer. So you have very high frequency satellite coming, ground proximity, weather, transporter. This is the navigation radio and communication radio of the aircraft. We have also the transporter over here, the fire extinguisher, pull out and switch. Flaps position also, we can set the flaps, as you can see. So we see the flaps, how we position in flight. Is displayed here. Now it's in transit, it extends to 30 degrees, it displays. So we have a horizontal stabilizer trim. We need to trim a little bit down, I believe, like this. We trim too much up. So you see it's 5 degrees. Now we'll decrease a little bit, like 4.75. We need 4.25 for takeoff. The horizontal trim stabilizer. So a couple more things to note over here. This is a fly-by-wire aircraft. It has its flight control computers to control the flight control surfaces. The flight controls, as we fly, we move the yoke or the side stick. In the Airbus, you have left and right turns in the Airbus 2.8 G. G is the acceleration of gravity in left and right turns, or 67 degrees in a flight maneuver with an average speed like 200 knots. And also in the climb you have in the Airbus like 15 degrees, 30 degrees and 1.5 G of climb maneuver. Also in the descent you have like 15 degrees, minus 15 degrees, or minus 15 degrees, or minus half G for descent. So also you can see climb descent over here. So climb descent, elevator climb descent, side stick input up and down, elevator up and elevator down. So we're gonna have more about the flight controls of the Boeing 787. So it has similar flight control computers inputs like in the Airbus aircraft. So the Boeings also have other flight control modes. We have the horizontal stabilizer cutoff switch here. We have the normal flight control computers, horizontal stabilizer over here for climb and descent. So you set the horizontal stabilizer over here, elevator trim for climb and descent. Also stabilizer pitch trim over here for climb descent. And now flight control computers, cutoff switches over here. So we cut off the horizontal stabilizer with this switch over here. You can see stabilizer trim cutoff switch. So we have a failure of the flight hydraulic systems over here of the Boeing aircraft that affects either left horizontal or right horizontal stabilizer movement and elevator movement. We open, we have the flight control computers over here. We're gonna lose the we're gonna lose the automatic trimming, because also this is fly-by-wire aircraft like the Airbus has the automatic trim, the auto trim system. As we fly, can trim the horizontal tail and itself automatically. So we're gonna lose the auto trim from the Boeing 787, and we have a failure of the hydraulic systems, as you can see also. So you can see the autopilot flight director system panel has its own auto trim function. So we need to come down here. This is for Boeing 787 aircraft and other Boeing aircraft, as you're gonna see now. We have also an incoming aircraft here. It's coming another one for landing. So we're gonna see here we have this is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 777 and Boeing 787. It's similar flight control system with automatic trimming. So we need to open this red guarded switch from normal to cutoff position. If you have a failure of the hydraulics and you cannot use the stabilizer trim, you can use then only the alternate manual trim switch over here, nose up and nose down. I think Embraer aircraft has similar function control for the stabilizer trim, and CRJ Canada aircraft. So we have the horizontal stabilizer, the manual pitch trim over here. All the time you can trim manually the horizontal stabilizer of the aircraft as you fly. So you use only alternate pitch trim, manual and normal. So I'm gonna show you the other flight controls now. The displays, autopilot flight director system panel over here. You're gonna see the display, primary flight display. You can see here we have the airspeed tape, the airspeed indicated, airspeed selected from the autopilot flight director system panel, barometric altitude above the sea level, barometric pressure of the outside atmosphere. So we need to set the barometric pressure altitude over here to have the correct altitude reading as we fly. So we set over here from the FE's electronic flight instrument panel. You can have it right now 29.92 inches of mercury, and also you can set inches of mercury of hectopascals by turning around the switch and increase and decrease the reading of the barometric pressure altitude. Over here we have minimums, radio and barrel set for display. So barometric pressure 1013 hectopascals, so 29.92 inches of mercury over here. Also the range of the aircraft, increase and decrease the display, the plan, menu, map, weather radar, traffic, terrain, radio minimums, flight path vector, meters, accept, cancel, reject some warnings, the display of the warnings over here. So we have also, you're gonna see all the Boeing aircraft flight controls and systems. You can see systems, CDU, info, checklist, communication, navigation display, engine, ACAS, cancel, reject. The range right now is 18 nautical miles over here. So we have another aircraft coming for landing, another Boeing 787, as you can see, 737 800, as you can see. So here we spotted another one. So you can see we have the barometric pressure 1013 hectopascals, so 39.92 inches of mercury. You can increase and decrease. It will display a different an increase or decrease of the barometric setting altitude over here. So right now it's 39.92 inches of mercury. We have radio minimums, altitude, landing altitude select, no V speeds. We don't have the takeoff speeds right now. So we have 1430 feet above the sea level. You can see the elevation also displayed in the terrain as we fly over here. So we have the terrain, the elevation above the ground level. You can see here as we fly with the yellow and red and green indication. You can see the flight level. The distance right now is 80 nautical miles, 40 in the middle, 0 where the aircraft is located. right now displayed. So maybe a better view, more clear view over here. So you can see the range over here, 80 nautical miles, also selected from the range setting over here. We have the plan also, the map, the terrain. You can see the Düsseldorf airport, France over here, Germany over here, and Switzerland. You can see the terrain elevation, like you can see like 4,300 feet over here, maximum 4,500, 1,600 with yellow, red and yellow. And now we have green also when we fly. So we'll increase the range. You will see more airports. You can see Germany over here, EDF is LF is France over here, and Switzerland is over here. Swiss also, if we decrease it, you will see also higher flight levels over here as we fly above the ground level. You can see also we decrease the range a little bit. The terrain we have in front of us, some mountains over here in front of us, like 30 nautical miles we need to climb. You can see the settings 10,000 feet are selected from the autopilot flight director system panel over here. We have the same selection from the autopilot flight director system panel, also displayed in the navigation display. So we're gonna set later in a couple of minutes. You can see also in the primary flight display we have the display airspeed indicated, barometric altitude, and also the vertical rate of climb descent of the aircraft, like 500, 1000, 1500, 2000, 3000, 6000 feet per minute. For climb you see the needle moving up, for descent you see the needle moving down. Also the pitch ladder will decrease over here, like 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up, pitch down. Also the bank roll turns like 5, 10, 15, 20, 30, 45 degrees left and right turns. The wings of the aircraft, wings level. So this is the flight director crossbars, and also the side slip indicator. Radio altitude above the ground, it will display like 2,500 feet above the ground level. The HSI, the voice stations here, receivers. So this is the Boeing 787. You're gonna see also the flight management computer over here. In a couple of minutes I'm gonna show you the engines first. So the engines indications. So we have two General Electric GNX engines for the Boeing 787, turbofan engines, one left wing, one on the right wing. For symmetrical thrust and radiuses, one contains a FADEX. The FADEX are the full authority. This is electronic control computers, one installed per engine gearbox, dual channel redundancy. When it's on phase, the other takes over, controls motions, and display all the engine data. You see the upper and lower ACAS, engine indication, control system display of the aircraft. Like the N1, which is the low speed sub low pressure compressor and turbine of the turbofan tube, which is engine the exhaust gas temperature per engine. The N2, which is the high speed sub high pressure compressor and turbine of the turbofan tube, which is engine the fuel flow points per hour, 1000 kilograms, 1000 pounds, soil pressure, temperature, quantity, and the vibration of the N2 stage of the engine. Also, we have the outflow air from the 59 stage from the front fan, used for cabin pressurization for oxygen supply in the flight, when flight high air levels. We have also the air conditioning, ventilation, hydraulic fluid tanks. The engine pressure also pressurize the hydraulic fluid tanks. Also we have the wing and engine RDIs, and also the hydraulic fluid tanks that pressurize the flight control surfaces. For instance, the thrust reversers for the engine, landing gear, external retract, parking brakes, rudder, all flight controls you see. Also we have the FADEX control, the fuel recirculation from the left and right wing in flight to heat up the fuel so it won't freeze. Also the lubricant and the oil, we have the recirculation of the fuel system. So you're gonna see in a couple of minutes. So you can see here we have the FADEX, what it displays the engines indication. I will show you the N1, which is low speed sub low pressure compressor and turbine of the turbofan tube, which engine exhaust gas temperature per engine left and right. And 2, which is the high speed starter sub high pressure compressor and turbine of the turbofan tube, which engine fuel flow points per hour, oil pressure, oil temperature, oil quantity, and vibration of the N2 stage of the engine, cabin pressurization here. Pressurization where we fly 1,400 feet right now. Rate of climb descent differential pressure will go like 7.8 or 8 psi. Flight altitude, landing altitude, and the outflow valves position. We have the landing gear here, extended retract, up and down. Other settings, auto brake, also auto brakes, rejected takeoff for flight, landing, auto brake. You see auto brake set over here. I will display auto brake 1. So we have alternate gear. We have failure of the gear and the lock override, extended retract speeds for the systems. So I'm gonna show you now. I'm gonna set up the flight management computer. I'm gonna use the flight management computer to input all the data of the aircraft for this flight. I will input the takeoff gross weight, and includes the empty weight plus the passenger plus the cargo plus the fuel on board, with the fuel is stored in the left and the right wing in the center tank. We have 30% in the left and the right wing, 10% in the center tank. So the flight management computer is going to balance the aircraft from takeoff, climb, cruise, descent, approach, and landing. We're going to have the fuel burn. Also the attitude of the aircraft in flight will change. So we're going to have the center of gravity is recalculated automatically. We don't need to do nothing. It's calculated by the computers of the aircraft. We also use for the flight control computers and the autopilot flight director system panel. Also, when we fly manually the aircraft, there is no difference, or the autopilot is we have balance of the aircraft in the air. Also, we have for flying for takeoff horizontal trim stabilizer position. We're gonna set it using the center of gravity of the aircraft position and the mean aerodynamic chord position, and we're gonna use 15 degrees of flaps, 4.25 degrees of horizontal trim stabilizer. We're gonna use the runway for takeoff, runway length, runway slope, wind direction, and speed, barometric pressure, and the temperature. We're gonna use takeoff thrust like 90% or 100%, 99 or 100%, and 9 degrees of pitch altitude for takeoff. We're gonna climb from the runway 14 in Zurich. We're gonna climb to the cruise level of 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints. We're gonna use the CIS other instrument bars, waypoints, and fixes that include horizontal vertical navigation fixes on the speed constraints. Then we're gonna descend back to the elevation of the airport, like 7 or 6,000 feet above the sea level. We're gonna descend for approach, aligned with the stars. These are the terminal arrival waypoints and fixes that are gonna be aligned us with the runway. Magnetic North Pole heading 136 degrees for the runway 14. So we're gonna use the stars and also the Lszh localizer, the instrument landing system. We're gonna tune the Lszh frequency for each runway we use for takeoff and for landing. Separate radio frequency. It receives the radio frequencies transmitted from the threshold of deadness of the runway for alignment with the horizontal localizer and vertical glide slope, and are received from the onboard deadness of the Lszh localizer of its aircraft. So I'm gonna show you how you're gonna use all that. We're gonna use 25, 30 degrees of flaps for approach, for landing. 35, 30 degrees approach landing flaps. Also, we're gonna use 35, 30 degrees. We're gonna use 160, 170 knots for approach and landing. Airspeed like 270 kilometers an hour. Pitch altitude like 9 degrees, and also landing gear extended. So you're gonna see the complete flight from takeoff, climb, cruises, and approach and landing. I'm gonna show you now how I'm gonna create the flight plan. I'm gonna use this mouse pad here and the keyboard of my computer. You can see the setup again. So I'm having the mouse pad of the computer here of the aircraft. So I'll use this mouse pad if I need, left, right, lower, the keyboard also, the screen display, flight management computer. So you can see the index here displayed. The index, embedded position, performance, takeoff, approach, and unseat status, flight plan. So we'll go back, the index over here. So I'm gonna show you this view of the flight management computer very quickly. We need also some lights on. So control, you can see the control panel again. Another nice view of the aircraft of the Boeing 787. So we use identity over here is the Boeing 787 with GNX engines, the air cycle, the position, Lszh airport, Zurich International Airport in Switzerland. Also the alignment, the IRS alignment. You can set IRS alignment over here. Position, performance, So we're gonna set takeoff, gross weight, fuel on board, and the gross weight for takeoff, 0 fuel weight, cruising altitude, cost index, freezing fuel temperature, cruising, and reserve fuel. So we're gonna set the route, Lszh Airport, Zurich International Airport, in Switzerland, back and forth, copy paste. We use departures here for the Zurich International Airport. We're gonna use we can use runway 10, 14, 16, 28, 32 over here. So we're gonna use runway 14 for takeoff and the Zurich to Alpha for approach and landing for arrival. So we have also for arrival we can use 16 to 8, 34 ILS, 14 ILS, 16 ILS to 8 ILS, 34 GLS, 14 localizer, 34 localizer. So we're gonna use ILS 14, trans Amiki, and trans over here Negria, over here Negria 1 Alpha. So we're gonna have the alignment with the ILS localizer. We can set here the route is active, but it's not yet active. It's displayed with blue, but it exists. So we have all waypoints from takeoff, climb, cruise, descent, approach, and landing. Cancel over here. Discontinuity. So we set departure over here, arrival, ILS 14, trans Amiki, trans the stars over here. Next page, Negria 1 Alpha. So we have the legs here. Runway 14. So we set the reserve fuel for this flight. So we have 5% over here. 5%, the cruising altitude 35,300 feet, and the cost index 100%. So we set 100% over here. Fuel temperature, fuel freezing temperature, the legs. So we press the execute here button, and the active route is created. So we have the route to fly over here from first waypoint, second, fourth climb to the cruise level. Zui, we make left turn 6000 Alpha, Negria 071, 36 nautical miles from Zui. Mativ, then descent, approach, and landing. Zurich 701, the runway. So you can see the waypoints. We have departure, arrival, alternate, VNAV, progress, FMC communication, hold over a waypoint over here, fix navigation, radio. We can tune the ILS localizer and do other things. So we go back in the over here. We need to start the APU very quickly. The auxiliary power unit, we're gonna start the engines. With that, when we start them down, we have left and right engine, IDT, 180 to 200 volts for 100 frequency in the battery. APU, normal, primary flight control computers, air data computers over here. Heading reference, flight controls, the battery for down bar also. Passenger oxygen, window heat over here. Primary and demand hydraulics, we turn off, you will see what happens. Display a fault condition, so we need to reset back to the on. And we have electric also. We have the recorders, we have the cargo and APU fire. We have electronic engine control with the auto start system. We can start the engines. We can dump some fuel in flight to make an emergency landing, lose some weight. If we arm this, select the nozzle, how much fuel to remain. We have the crossfeed valve, so we turn it on. You can feed either engine with either pump or either tank. We have left and right wing fuel booster pumps and center tank fuel booster pumps, the balance. So we can also balance using the crossfeed. This is left and right wing fuel tanks. We have the wing and engine guides over here on and auto. Some systems, not all. Cabin pressurization here. Manual, we use the outflow valves for climb descent. The pressurized the aircraft. Also in the auto we need to do nothing. We have the air conditioning for ventilation and oxygen supply in the flight. We can supply with oxygen the aircraft all coming. So we have also over here, we're gonna restart the engine, so we need to see last systems over here. System display, CDU checklist. So we have the systems over here displayed. So in the overhead panel you see the hydraulics, APUs running, oxygen, liquid cooling over here. The electric over here, left and right IZ, 100 to 200 volts, 400 Hz frequency. The APU is running. The main battery in the APU, battery voltage and amperages, and the load cell, hydraulics, where the hydraulic fluid goes with systems use hydraulics, left and right engine, and electric C1 and C2. Pressure 5100 psi, and the quantity of hydraulic fluid, set-off valves, and the systems. We have left and right wing, fuel tank, center tank. This is the fuel page. You can see the engine symbol. Low and high pressure fuel valves are open and feed both engines from the center or left and right wing. The APU is fed from the left wing. Is this motor. The cross-feed valve is off, but we'll turn it on. You can feed either engine without the pump or either tank. Also, the minimum fuel temperature below which the fuel freeze in flight -37 degrees. You can see in the -6 is the fuel temperature right now. So we have also the air pressurizer, air conditioning. The doors are closed. The cabin can be pressurized. The gear, temperature of the brakes, and pressure of the tires. Flight controls here. You can move the flight controls left and right. Climb descent also. Radar. So you see the flight control deflection. FS display. Maintenance systems and circuit breakers. Also we have last thing to do, the checklist, normal menu before takeoff. Also we have the communications using the computer, approach, descent, and landing. So we set back navigation display. So we turn off both engines very quickly in the off position. So you're gonna see what happens. Both fuel control, fuel valves off. You're gonna see the starvation of the engines from fuel. So fuel pumps are going in the amber. So you're gonna see now how we're gonna restart the engines. The Boeing 787. Hope you like my aircraft. So we're gonna reset very quickly. We go in the overhead panel and restart the engines. Both engines in the auto start. You see the reconfiguration of the switches in the overhead panel with amber color light. So we have now a pressurizer inside the N2 stage above 18%, 19%, 20%. So now we can let the fuel flow. You can see we have only pressurizer right now into the engines from the APU is admitted. So we let the fuel control on. Both fuel flow valves open. So we have about 1 minute to go for takeoff. So auto start proceeds, 28%, 29%. You can see now we have both fuel and also and pressurizer from the APU. So the auto start proceeds. The amber lights off. Now we're gonna see the running engines symbol over here. So we have running engines. We can go for takeoff. Set the flaps for takeoff over here. Have no time to set the autopilot. Flaps for takeoff. Speed brakes up. So parking brakes off. We're gonna set the autopilot later. Only DL now. We have the time to set. It's no problem to us. We can set the autopilot in flight. So we take the air traffic control clearance from the air traffic control. So the runway is open for us. We use the tiller for alignment over here. So we align with the center line, as you can see. So we have the center line here set. We apply takeoff, maximum takeoff thrust over here, and we push the side stick down, or the yoke of the Boeing, the side stick of the Airbus, as we apply takeoff, full takeoff thrust until 80 knots. So we have 80 knots. We can leave the yoke up 120 over here at V1. We start pitching up the aircraft slightly, like 9 degrees. So we have the positive rate of climb and rotation over here. So positive rate, landing gear up over here, keep climbing. So you can use see the displays after takeoff. You see the airspeed 200 knots. We are 1,600 feet above the ground, 1,800, 2,000 feet above the ground, but 3,500 above the sea. We climb with like 6,300 feet per minute. You can see the stall speed indication, the wind direction speed, the red, green, yellow, the terrain. Also here the flight plan. Also we're gonna fly above the terrain. You can see the elevation here, symbol for the flight directors. So we need also see around. So pay attention to the airspeed, the stall speed, red and amber indication. You can see the ground below us as it displayed. So we're flying like 4,500 feet right now. Over here is displayed 4,700. You can see we are 4,000, almost 5,000 feet above the ground. And the ground is displayed with this green wave line over here below us, also around us in the map display. So we're gonna start the turn now as we depart the airport. Zurich airport over here. This is the runways, also the Switzerland. So we're gonna have the turn now. Start turning. Here aircraft, as you can see. And keep climbing also as we make the turn over here. So we have like 13-14 more minutes for this flight, for video to end. 13 minutes. So you see the air dot again after the turn we did, also the engines indication. We have also the outside view of the aircraft as we fly through here. You can see the airspace above us, also the star sign, very beautiful other aircraft that fly close to us. So you can see the aircraft, the Boeing 787 as we climb. So this is the Switzerland all around. Also we're gonna fly through over here. You're gonna see so we need to align here a little bit, as you can see. Hope you like this view over here. So we climb through. You see the airspeed indicated 176 knots, the stall speed, other data, and this beautiful view over here as we climb through the Switzerland. I'm gonna make the turn now. Have like 1 more minute. Need a little bit more, less flaps. So we start turning, alignment with the waypoints here. You can see the head-up display, the airspeed and the altitude above the ground. Right now, the airspeed increases, flight directors on and off. So we keep climbing a little bit now. Again, you see the climb. I push the yoke up the side stick, so it gives me the indication that we climb. The airspeed, the stall over here, we need to avoid stalling. The waypoint, we have to cross through the wind speed over here, the ground speed of the aircraft. First waypoint is the Zui over here, 1.9, 1.8 nautical miles. We are approaching the Zui, so we made a very good intercept here for the Zui. Waypoint, we need also to make a turn here, align with the flight plan, as you can see. So we are aligned with the LNAV, the lateral navigation of the aircraft. So you can see we are overflying here the France over here, the Germany, my homeland, Germany, Bayern Munich in front of you. Beautiful, and also the Switzerland, the lakes, and the Swiss Alps. So we need to start the turn right now, as we are going here through the navigation again. We're leveling off. You can see also we need to start the turn back to the airport very quickly. Keep climbing also. So we use a little bit right rudder pedal here for this turn to make more steep the turn. I was climbing also. You can see we overflying Germany, Bayern Munich in front of us, and the lakes, beautiful lakes, and the France over here. So we are at 21,000 feet, 7,300 meters above the sea, as you can see. The Boeing 787. Hope you like it. So we need to come back for alignment with the waypoints here, with the flight plan. We have a few more minutes to fly. So use maybe more flaps for the turn, because we made very rapid climb, and also more right rudder for more rapid turn over here. So we are leveling off. We can leave the hands off from the side stick or the yoke, no problem. The aircraft keeps flying the way it should be. It's fully aligned. We can only trim a little bit and increase the airspeed if we need. So you can see we keep climbing a little bit higher, and we need also to have the outside view of the aircraft right now. We're gonna see the chemtrails over here, the frozen vapors from the engines. So make left and right turns over here as we fly in the frozen vapors, as you can see. We're flying this area. So we have also the star sign. You can see beautiful star sign, the galaxy over here. So we overflying here Switzerland, the lakes, the Germany, and also the France over here. So hope you like the star sign here, galactic star sign, very beautiful. Overflying the Swiss Alps, this Alpine view. So we need to start the descent now. Descend back to the airport. Idle thrust. Also flaps up. Retract the flaps, speed brakes down, and increase the airspeed. We are overflying the airport right now. We have a few more minutes, so we're descending, as you can see. So this is the descent of the aircraft. We're going back to the airport. So we make a quick descent. You can see the runway we're gonna use for landing over here. You can see the view of the cockpit right now. Hope you like it as we are descending over here. One more view of the cockpit of the Boeing 787. Full view. So we need to increase the rate of descent over here. Use idle thrust for now. So thank you for flying this beautiful jet aircraft with me. I'm only flying jet aircraft. So you can see the point of intercept here as we descending. It shows us we're gonna be leveling off with the autopilot setting right now. Over here you can see the autopilot settings of the Boeing 787 right now for approach. So to descend, we have to cross through these waypoints for approach. Over here, 15,000 feet. So we need to start the turn now for approach. Keep descending. Push down the stick. Make a more rapid descent over here. So you can see we are descending over here. We need to align, we use a little bit left rudder now as we turn, and descend a little bit more rapid. Keep descending here. So make full left rudder now and make an increased airspeed approach and landing over here as we are approaching. We have 2 more minutes left. You can see we need to align with the runway. We have the runway here, so full controls now. For alignment, you can see we need to align with the display. Keep descending. We need landing gear down in a couple of minutes. We need 1 more minute and a half for approach over here, as you can see. So can be landing gear down. Over here, advance the thrust, the engine. And also flaps down over here, as you can see. So we are approaching for the landing over here. Align with the Lszh localizer. So we have the Lszh localizer here displayed, as you can see. What we need, all the information as we are approaching for landing to the runway. You can see the runway here. So we increase the airspeed a little bit. We have a few more seconds for approach and landing. A few more seconds, maybe we won't gonna make it because the video will end like 25-30 seconds more. We have 15 more seconds for the video to end. So we are aligned for the touchdown. Maybe we're gonna make it only for the touchdown, as you can see. So we're here for the flare. Idle thrust for flare. put touchdown over here. So we're gonna touch down here, as you can see, very beautiful touchdown. Parking brakes on, all thrust reverses, parking brakes, and thrusts are reversed.